Hey everybody, this is Larry. This is Tuesday, February 18th of the Leetcode Daily Challenge. I clicked on the button, I thought, but maybe not. I lied. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's farm. Yeah. Today, again, no update on the running. The foot still hurts. I haven't ran anything. Still a couple of days more to another doctor's visit. We'll see how it goes. I did donate blood today though, so that was good. So always be donating blood. It's good for you to actually donate blood because you get rid of extra iron, what they call forever chemicals, and also just like other things in your body that you might not need. So it's good. Yeah. What was I gonna say? Oh yeah, and today I've just finished reading Andy Weir. Maybe I'm saying his name wrong. The guy who wrote The Martian, his other book, Hail Mary, which I've been, it's been out for a few years, so it's not new, but I finally got to it, and it was good. I don't know if it's good for everybody, but as a physics nerd, it's just a lot of like, for me, it just reminded me of reading like Sherlock Holmes, where like, oh, you see a problem happening, you're like, oh, how would I solve it? That's how I read it anyway. I don't know if that's how people read these books, but in any case, yeah. Let me know if you read this book or even The Martian, or if you read any good books recently, because maybe I need to maybe I'm up to another book. Anyway, all right, let's take a look at today's farm. We have 2375. Construct smallest number from D1 string. I don't know what that means, D1, but okay. Okay, in zero index pattern, you're given a zero index string pattern. I mean increasing and D means decreasing. You can create a string in the following way: num survive 1 to 9 only, at most once. If the pattern's I, it has to be increasing, and if it's D, is decreasing. Return the lexicographically smallest possible string that meets the condition. I think these problems can and cannot be interesting, or can be not interesting in isolation, but it is just like really awkward that we're kind of doing this in like a phrase kind of way, right? Like we're doing this all week. A phrase? Did I say phrase or face? But anyway, we're doing this all week, so it's like a little bit of a cheat to kind of think about it. The first thing I would do, I mean, I don't even have to look at the constraints too much because they're only 1 to 9 digits, so it really cannot be more than, say, 9 factorial, right? Don't get me wrong, 9 factorial is, what is it, like 86,000 or something? I don't know, something like that, right? Oh no, what am I thinking of? Maybe I'm thinking of 8 factorial. I don't know. Alright, I was off. I'm thinking of like seconds in a day or something. Because there is like a very weird like coincidence. I don't know if y'all know this, where like time, was it seconds in a year or something? Maybe it's not seconds in a year. I forget what it is. There's like a weird one where oh no, minutes in a is it minutes in a year? I don't know. There's like a weird one where man, okay, today I'm blanking out, but there's like a weird factorial one where it is like somewhat important in like time in a like seconds in a day or something like this. I don't know how many seconds are in a day. 86,000, right? Yeah. I don't know. Okay, never mind. It's not that important. But anyway, my point is that 9 factorial is not that big. My apologies. I have so many constants and random trivial facts in my head that sometimes I'm not able to access them. Or at least maybe I did when I was younger. But maybe not anymore, I don't know. I'm just like, all these things I'm mixing together, and I'm just like an old guy going, factorial. Anyway, there's only 9 factorial in the worst case, and you can even do memorization, so it's not that big of a deal, right? in some way, right? Because they're only keeping in mind that if you have 9 numbers, there's only 8 things in between. So 2 to the 8 you can actually memorize, so it's not that big of a deal. And we watched yesterday's problem. I did kind of go over one way to memorize, even if it's not the cleanest way, right? So yeah. Okay. So I don't even have to look at the constraints, and sure enough, the constraints are what we said anyway, because they don't have to abide by this, but anything more than that, it will just never be possible, right? So if it's not possible, then you know, there's no point. But anyway, so yeah, even 9 factorial is good enough. And with this one, we're trying to get the lexicographically smallest. And you already know this. You know, especially if you watch the last couple of days, you already know that I'm going to say, like, what is lexicographically smallest? Well, it just means that in a way, you want to be greedy on the first digit as much as you can, right? That's the basic idea. And sometimes there are other ways to do this, but when you see this, first thing you can do, the first thing I do anyway, is just try to think. It doesn't have to be greedy, but it just has to, you know, you just have to be able to test it, right? And what I mean by that is that lexicographically smallest means that the first digit matters more than all the other digits. And then you think about that recursively. So it doesn't always have to be the first, but first and then second and then third, right? And what I mean by that is that even if you have all 9s, if the second number is, you know, all 0s, it doesn't matter what the second number is, because if the first number is the biggest, then the rest of the ring is, right? And the way that I solve these lexicographically sorted problem is I just do it 1 digit at a time. Sometimes and then you do like something to check, right? Like basically this is the core, I wouldn't say pattern, but a dot process would be like, okay, can the first digit be a 1? Can the first digit be a 2? Can the first digit be a 3? And in some cases, that question can be answered in maybe O of n time, O of n squared time, whatever, right? I mean, you do the math whether that is, you know, it's good enough, but that's basically the idea. And in this problem, you know, it may be that the answer for the rest is going to be n factorial. It's like, okay, can it be 1? Well, it's n minus 1 factorial to check. And that's okay, right? Because it's okay because, yeah, it's fast enough because n is at most 9 or 8 or whatever you want to call, however you want to phrase it, right? 9 minus 1 or something, right? So, but those are the ideas that I do for everything. I mean, even on the harder variation of these lexicographically smallest problem, I might go like, okay, well, and don't get me wrong, it doesn't make it easy because this is just the first part. But for harder problems, it may be that, oh, can we check? And this is actually also come up sometimes with digit DP as well. But you go, okay, well, is the first digit a 1? Okay, well, in order to check this, I have to solve this dynamic programming problem. Okay, well, I mean, it is easy to say, right? It's simple to say, but hard to actually solve. But that's still how I think about these problems, right? Okay, so that's basically it. I mean, yeah, I mean, I think I'm just going to brute force this one, right? Like I said, even if you are very, as long as you're not like crazy lazy, it's going to be at most 9 factorial, and that's going to be good enough, right? So yeah. And as I said, you can memorize this actually, right? So if you really want to do that, maybe that could be an upsolve. But today, I'm not gonna lie. Like I said, I've spent like 6-7 hours or whatever it is. I don't know how long it took me to read the book. So I actually am recording this video pretty late as a result. So yeah, and all that means is that I need to go to sleep soon. So my apologies. But yeah, I think I've given, well, we'll try to solve it, and we'll see maybe that I've given all the tools to kind of do a DP, right? Okay, so how do I want to write this, right? So here, I'm just going to call everything go. I'm a little bit lazy today. So we have the index, right? And then maybe, do I even need the index? Not, maybe not. Maybe, I mean, not if you do everything like in a pure whatever kind of way. I think what I was going to say is that technically you don't need, I mean, technically speaking, there's nothing in the criteria itself that restricts the digit from 1 to n, meaning if n is, oh, actually I'm missing 1 anyway, but And what I mean by that is that, oh, actually, I guess I do need index. I mean, I don't need it, but it's a little bit easier because I forget that matches this. But what I was going to say is that, yeah, for example, if it only has 2 digits or one thing in the pattern, you can actually use like 89 if you want. But you can also prove very quickly that that would never be lexicographically smallest just by symbol. I mean, you can probably symbol look at it, but if you want to do a proof, you can do that as well. So as a result, anytime that you have a number, you can replace, if you can replace it with a smaller number, you should. And as a result, then it's going to be bound by the smallest n digits. So that's just to kind of get you up there, right? Okay, and then here, I always don't know where. I mean, I guess I do. It almost doesn't matter where I pass it in or not because I don't. Because the thing is that I don't construct a new thing for it usually, because if you're going to do bounce, so the thing is that if you do dynamic programming, you do need to keep track of the states somehow, right? But if you don't, if you're just doing branch and bound and recursive things, as long as you're really sure about your invariants, doing it in the global versus passing in a pointer reference doesn't really change that much. I mean, you can make an argument about pushing an extra point on stack, but it's a couple of bytes. I'm not, it's not something that I worry about, right? Anyway, so yeah, so then we are done, right? Then we're good. So then maybe we have an answer. You go to none. Answer is equal to current. Make a copy of it, and then yeah. And then anytime we branch, if answer is not none, then we just want to terminate because we're already done. So let's just return, don't do anything more, right? Yeah. And then we have a for loop, right? We just go from 1 to 9. It's not a big deal. Or from 0. Oh, actually 1 to 9. No zeros, right? Yeah. And yeah, if it's not used sub I, and also if while answer is none, I don't know which order is better, but why the same, right? Then we just do it, right? Change state, current dot append I, current dot append current dot pop. Well, you have to do one more thing. Actually, I messed up here already because I just forgot about the pattern thing, right? Yeah. So then now, if pattern sub index, I'm trying to think how I would do to kick off the first digit. The base case are actually kind of interesting, but yeah, I mean, no, I think this is a little bit better. We'll just have to kick it off with one thing. But yeah, if this is equal to increasing, then we just look at the previous number, which is the top of the stack. So current sub, just the last digit is fine, +1, right? Inclusive, right? And then else we do the same thing, but I don't know if it's worth writing like a different for loop for it versus just copy and paste. But yeah, so then we have 1 going to here, right? And that's really it. Well, I mean, really it if I had done this correctly and just remember next +1, right? And then of course, like I said, you do have to kick it off with the first digit. I mean, you maybe could put in as part of the function, but maybe it's fine, right? So and I know that you can actually just like replace the last number or something like this, but I feel like this is a little bit, I mean, it's a little bit slower, but a little bit, like cleaner with respect to state management. So yeah, so then here we go from 1 for the first digit. And then yeah, and if we always have something, then at the end we should be good with return answer. And yeah, let's give it a spin. I forget to do non-local answer. I guess that is a thing that happens with this, with assignments. But yeah, string out of. Did I miss by 1? Oh no. Yeah, oh, then this is wrong because this is on the thing. No, is it? No, this is wrong. This is off by 1 because I was debating about counting, and of course I have to convert this to a string. But I was debating between counting Oh, and I forgot to use tier, so that's why. But that's an easy fix. But yeah, yeah, because the n initially I thought the index would correspond to the numbers itself, or the number on the index of the answer that we are populating. But then I changed my mind. That's when you saw that I removed it. And then, but I was like, oh wait, but you kind of do need it as part of pattern. I mean, you don't actually need it still, honestly, because you can use it as part of the like you could actually just write like index is equal to like length of current or something like this -1 maybe. But I don't know. I sometimes I don't know. There's there's no it's not that big of a deal, is my point. I mean, I don't know if it's a good answer or not, but that is what I would say. Oh, and I still have to I mean, the only way that this would happen. Wait, what? Oh, in this case, I guess I have to fix this, because in this case now we only go from. Well, we also go. I made some mistakes here because just very sloppy, but I'll go over it real quick. So n is just the number of numbers, but I think about them from 0 to 9, just because 0 index, just because it's very natural to do so. But this should be like, you know, so that you have one offset and also to get n, right? It's still not quite exact, because now we count up to 10, which we shouldn't, right? It should go only up to go to n plus 1, I think. It's either n or n plus 1. Maybe it's n. Because I forget how. I mean, not that I forget. I could have just looked up it. So, that's unexpected. Maybe. I mean, you could fix this by just going like, you know, and then see if that fixes it. That means that, yeah. But it's still very wrong. So there's some funky things going on. So maybe I'm wrong. So the reason why I've been doing poorly on this, and that this, I don't know, it's just that, well, one is because I'm rushing it, and the reason why I'm explaining this instead of just fixing it is because I want you to understand how these mistakes happen if they come up to you, right? It's because I try to conflate n on a number of things, right? N is a very lazy thing, and in general be right, but what I need is actually, I don't know, I have to define it, right? N is the number of unique numbers, right? So then here we actually because this is 0 indexed, you either have to index it -1 or you just add an extra 1. So I think this should be good. I mean, obviously it's not, because there is some other stuff. It's because we go up to n. But I don't. Oh, here. No, I forgot. Okay, I actually didn't see that it aired out here because I fixed it here and I was confused. But this is also why, in general, you don't like to code. I think this is also wrong in general because I forgot to do n plus 1. It's still wrong, but yeah, let's be a little bit precise. So index now. I don't. Because, oh no, it shouldn't be n -1. It should be the length of pattern -1, which is y, or length of pattern, which is n -1. But I feel like this is a little bit clearer because it leads to confusion, and clearly it was led to my confusions as well. Number of unique numbers. So I'm trying to think whether this should be n or n plus 1, right? So, and the way that I would think through stuff like this when you see is just use actual concrete examples. I'm giving you all my debugging tools here. So even though this problem may not be that bad for you, hopefully you like it. But yeah, if pattern has four characters, which then n is going to be 5, going from 1 to 5, and n is going to be 5. But because this is exclusive, this needs to be +1, right? But yeah, as you can see, this is basically right. I just have to convert it to a string. Yeah, it looks okay. So let's give it a quick submit. Hopefully no more silly mistakes. And there you go. We didn't even have to optimize it with DP. Apparently, this is pretty fast. Yeah, I'm curious how many. I mean, I guess if there always a solution, it goes through pretty quickly. But I don't know. Like I said, 9 factorial is also just not big in the worst case. Or even if you think your coding is bad, 9 to the 9 is not that. Actually, that is pretty bad. I don't know, but I guess yeah, if there's always a solution, it's probably not too bad. You get a lot of self-filtering earlier on. What would be the worst case? Maybe all D's for my example, because then the first loop it does all 10, the second I don't know. But yeah, that is all I have for this one though. Let me know what you think. Yeah, and I mean, you could probably do tighter bounds, but everything is going to be input sensitive the way that we do it. And like I said, the worst case is going to be 9 factorial, I suppose. You can constrain this a bit more with dynamic programming. The key thing to note is just and I'm not going to do it, but for upsolving at home, maybe you can do it, which is just to the state in that case is actually the number of numbers you have left, right? And it doesn't matter. Well, the numbers you have left, and of course the remaining things of the pattern, but that doesn't change on the state, right? So it's going to be just the number of numbers you have left, and that is enough because it actually does not matter what the previous number is, right? Is that true? Am I lying? Yeah, maybe I am lying. Huh. Well, I don't. What am I thinking of? Maybe I am wrong, actually. But in any case, even if that's the case, you can add a state, which is the last number, right? Which just adds like 9 more numbers, 9 more or 9 or 10 times the number of states, which is still pretty small. So it's gonna be like 10 times 2 to the 9, times 10 or something like that. Because index is also implied by the number of digits left anyway, right? So yeah, still gonna be faster, but as you can see, I'm not gonna worry about it. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.